Dart School presents multiplication of fractions. To multiply two or more fractions, the simplest rule is to multiply the numerators together and multiply the denominators together and have the answer as the product of the numerators on the top and the product of the denominators on the bottom. So for example, if you were to multiply the fraction 2/3 with the fraction 7/9, you would do 2 times 7, which is 14 on the top, and 3 times 9, which is 27 on the bottom. Similarly, to multiply 3/4 with 1/2 with 3/5, you would do a 3 times 1 times 3 on the top, that's a 9 on the top, over 4 times 2, that's 8, times 5, that's a 40 on the bottom. However, it makes sense to pick factors from the numerator and the denominator side that have got GCFs that are larger than 1 and then divide them with the GCF before multiplying them out. Consider this simple example. Let's say you want to multiply the fraction 41 over 80 with the fraction 80 over 41. Now obviously one way of doing this is simply multiplying 41 with 80 and have a product on the top, and then 80 times 41 have a product on the bottom, but then that will reduce to 1 because you essentially have the same number on the top as on the bottom. That leads us to the idea that if you see a factor on the numerator and a factor on the denominator, they don't have to be immediately one below the other, like this 41 and this 41 out here. If you could reduce those factors, meaning divide each one of them with a certain number, in this case 41, and in the same way go on to divide 80 with 80 and 80 with 80, you will not need to do the multiplication at all, because this becomes a 1, so does this, and this, and this. So this is 1 over 1, which is equal to 1. Now that was an oversimplified problem, I would say, just to give you a feel of what's coming next. Let's consider a more real example of trying to multiply the fraction 4/5 with 25 over 28. Now instead of doing a 4 times 25 on the top and 5 times 28 on the bottom, and then going on to reduce the new fraction that you have, let's not forget that the numbers are going up because you're multiplying. So the simplification process also might take you a while to do. Instead, if you could only figure out that there's a 25 over here and a 5 over here, and they do have a common factor, so we could divide 25 with 5 and 5 with 5, and do something similar between 4 and 28, divide both of them with 4, their greatest common factor. Then this number out here is a 1, and this number out here is a 1, and this one out here is a 5, and this one out over here, 28 divided by 4, is 7. So the answer is 1 times 5 over 1 times 7, which is nothing but 5 over 7. So you didn't really have to deal with those big numbers you would have got if you had multiplied the factors out on the numerator and on the denominator before reducing them. And let me tell you, the reason this method works is because the commutative property works for multiplication, which means that if you think about multiplying these two fractions in the normal way, it's like saying, okay, 4 over 5 times 25 over 28 is equal to 4 times 25 over 5 times 28, and we could always change the order of multiplication, and that's what we call the commutative property of multiplication. You can multiply numbers in any order, it still gives you the same answer. So you could just rewrite this as a 25 times 4 over 5 times 28, and now if you look at the two pieces, this one might be one single fraction, 25 over 5, and in that case you would have reduced it, right? Same with 4 over 28, which means this problem out here is the same exact problem as 25 over 5 times 4 over 28. As long as you have the same factors on the numerator and on the denominator, the answer is still the same. How do we then multiply mixed numbers together? For example, let's try multiplying 1 and 4/5 with 2 and 1/3. All you need to do is change the mixed number over to an improper fraction and do the same for every mixed number you have in the product. 1 and 4/5 changes to 5 times 1, that's 5, plus 4 is 9. So we have a 9 on the top, 5 on the bottom, multiplied with 3 times 2, that's 6. 6 plus 1 is 7. 7 on the top, 3 on the bottom. And that is equal to, you could cross off the 3 with the 9. The GCF of 3 and 9 is 3. So if you divide this 3 with 3, you have a 1 year. And if you divide 9 with 3, you have a 3 year. So this is equal to 3 times 7 over 5 times 1, which is 21/5. And then you can change it over to a mixed number, which is going to be 4 and 1/5.